This is Algebra 2, Chapter 8, Section 6, Part 2, in which we will continue solving rational equations. As you recall from the previous video, we did one of the word problems, the solution type, and we ran up against the clock, so we had to move on to a second video for the other two types of word problems. This type is the streams, currents, rivers, and this also would apply to airplanes. Okay, so there and back type problems. Going places and going back to other places, back to where you started. So we have our friend George here rowing in a canoe, and he's out on some small stream. We know that if he was sitting in still water, he could row 6 miles an hour. Now he's going to make a trip upriver and back. It's going to take him 3 hours to go 10 miles round trip. Assuming that he went at a constant speed, he didn't speed up in places, he didn't slow down in places, he didn't get tired. Okay, I know that's not feasible, but we're going to practice it anyway. Assuming he went at a constant speed, I want to know how fast the current of this little stream is. Well, we know that distance is equal to rate times time. And we also know that the amount of time it took to get there, wherever there is, plus the amount of time it took to get back, should equal the total amount of time. So his total trip is 10 miles. That means he went 5 miles there and 5 miles back. Okay. In one direction, and it doesn't really matter which one, he's got the rate of the river, the stream, helping him. So he's going his 6 miles an hour, plus he's got something pushing him ahead. Going the other direction, he goes his normal 6 miles an hour, minus there's stuff pushing back against him, because he's working against the current or against the wind, or however you want to think about it. But together, this amount of time to go there plus this amount of time to come back equals 3 hours. Now we need a common denominator. So 6 plus r times 6 minus r is the common denominator. Just like we did before, I'm going to put that in red to show you that each term got it. And then I'm going to do some canceling. 6 plus r cancels out in this term. 6 minus r cancels out in this term. And I'm going to take that result over to the top of the next page. Now you'll notice I distributed 6 plus r times 6 minus r here. Now I'm going to distribute everything else. And something really nice happens here. The 5 r's cancel out. That makes me happy, because since they cancel out, I can just bring this 108 over, divide by -3, and I get r squared equals 16. Take the square root. R is equal to either +4 or -4. Well, in this scenario, we're talking real world. A negative stream speed doesn't make sense. So we'll discard the negative answer and report the positive. R equals 4 miles an hour. That's how fast the current is. Okay. We have one more type of these word problems. And this is the most commonly missed one because people try to go on autopilot and not think about what they're up against. Okay. We've got two people that are house painters. And it could be anything. It doesn't have to be house painting, but any kind of working going on. They can paint a house of a certain size. Anthony can do it in 10 hours by himself. Travis can do it in 6 hours by himself. The question is, how long will it take them working together to paint a house of that type? Now, a lot of people go on autopilot and say it's got to be the average of their two times. So 10 hours plus 6 hours and then divided by 2, it must be 8 hours. And that could not be more incorrect. If you think about this for just half a minute there, Travis can do it in 6 hours alone. If Anthony's helping him, it shouldn't take more than 6 hours. It should take less than 6 hours. What we really need to find is their work rates. Well, if Anthony can paint the house in 10 hours, he does 1/10 of the house each hour. Travis in 6 hours, so he does 1/6 of the house each hour. Working together, they do 1/x of the house each hour. So we need a common denominator, which I've already found for us, is 60x. Give it to each of them. We can reduce this fairly easily. 6x plus 10x equals 60. So 16x equals 60, or when we divide, we find out that it's going to take them 3 3/4 hours to work together. Which makes sense. It should be less than 6 hours. So we get a smaller answer. We're happy. It made sense. Just don't go on autopilot here. Don't make the mistake of trying to average the two times, because that doesn't work out. So that's what we've got. We're working with these word problems. We're working with the regular equations. And the key is to get common denominators to cancel these things out, and then work with what you've got left. Make sure the answers don't create a zero in the denominator. And make sure when you're doing the real application problems, you don't have negative answers that don't make sense. If you had questions along the way on either video, hopefully you wrote those down. Bring them in with you, and we'll see you in class.